Hello everyone, welcome back to the CSC Guide. Today we are going to explore some important concepts in first order logic, including its syntax and semantics, inference techniques, knowledge engineering, propositional theorem proving, and the role of logical agents in AI. So let's dive right in. First, let's discuss the syntax and semantics of first order logic. Syntax refers to the formal structure of the language. In first order logic, we have several key components. First, predicates. These are functions that return true or false. For example, human of Socrates is a predicate that asserts that Socrates is a human. Second, terms. These can be constants, variables, or functions. A constant is a specific object like Socrates or Plato. A variable can represent any object such as x or y. Functions can map objects to other objects like mother of x, which returns the mother of x. Quantifiers. This allows us to express statements about collections of objects. The two main quantifiers are universal quantifiers for all, indicates that a statement applies to all objects. For example, for all of x, human of x to mortal of x means for all x, if x is a human, then x is a mortal. Second quantifier is existential quantifier, which indicates that there exists at least one object for which the statement is true. For example, for each of x, cat of x means there exists an x such that x is a cat. Semantics. Semantics refer to the meaning of the statements. In first order logic, the truth of a statement depends on the interpretation of the predicates, terms, and the domain of discourse. For instance, if our domain is all living beings, the statement human of Socrates is true if Socrates is indeed a human in that domain. Next, let's discuss the differences between propositional and first order inference techniques. Propositional inference deals with whole statements that can be true or false. It uses rules like modulus ponens and resolution to derive conclusions from given propositions. For example, if we know P to Q and P, we conclude Q. First order inference, on the other hand, allows for more complex reasoning involving predicates and quantifiers. It can handle relationships between objects and make generalizations. For instance, for all of x, human of x to mortal of x, and human of Socrates, we can infer mortal of Socrates. Lifting. Lifting generalizes propositional inference in first order logic by allowing us to apply inference rules to specific instances. In propositional logic, we deal with fixed statements, while in first order logic, we can apply rules to variables and predicates, enabling us to derive conclusions from about entire classes of objects rather than just specific cases. Now let's explain the process of knowledge engineering in first order logic and discuss its challenges. Knowledge engineering involves designing and building systems that can represent and reason about knowledge. In first order logic, this means creating a knowledge base that encodes facts and rules about a specific domain. The process typically includes knowledge acquisition, knowledge representation, third reasoning. Knowledge acquisition is gathering of information from experts or data sources. Second, knowledge representation. It is encoding the knowledge in a formal language such as first order logic. Third is reasoning. It is implementing inference mechanisms to derive new knowledge from the existing knowledge base. Challenges in real world applications include complexity, incompleteness, and dynamic environments. Complexity is the real world domains can be vast and complex, making it difficult to capture all relevant knowledge accurately. Incompleteness means Knowledge bases may be incomplete, leading to uncertainty in reasoning. Dynamic environments means knowledge may change over time, requiring continuous updates to the knowledge base. These challenges make knowledge engineering a critical and often difficult aspect of developing intelligent systems. Next, let's discuss what a propositional theorem is and how theorem proving is achieved in propositional logic. A propositional theorem is a statement that can be proven true based on a set of axioms and inference rules in propositional logic. For example, the statement P or not P. The law of excluded middle is a propositional theorem because it is always true regardless of the truth value of P. Theorem proving in propositional logic is achieved through various methods, including natural deduction and resolution. Natural deduction is a formal system that uses a set of inference rules to derive conclusions from premises. Resolution is a proof technique that involves refuting the negation of the theorem by deriving a contradiction from a set of clauses. Limitations of propositional theorem proving include expressiveness, scalability, and inability to handle uncertainty. Expressiveness is propositional logic cannot express relationships between objects or quantify over them, limiting its ability to represent complex statements. Scalability in this is as the number of propositions increases, the complexity of proving theorems can grow exponentially, making it computationally expensive. Inability to handle uncertainty refers to propositional logic does not account for uncertainty or incomplete information, which are often present in real world scenarios. Finally, let's describe the importance of logical agents in AI and how propositional logic and first order logic are used to model intelligent behavior. Logical agents are systems that use logic to represent knowledge or make decisions. They are crucial in AI because they provide a formal framework for reasoning about the world, enabling agents to act intelligently based on their knowledge. For example, a logical agent is a medical diagnosis system might use first order logic to represent knowledge about diseases and symptoms. It can infer potential diagnosis based on observed symptoms using logical reasoning. Propositional logic is often used in simpler scenarios where the relationships are straightforward, such as in rule based systems. For instance, a home automation system might use propositional logic to control devices based on simple conditions. Example, if it is night, then turn on the lights. First order logic, on the other hand, allows for more complex reasoning involving relationships and quantifications, making it suitable for applications like natural language processing, where understanding the relationships between entities is essential. In summary, logical agents play a vital role in AI by enabling systems to reason, learn, and make informed decisions based on their knowledge. That concludes our discussion on first order logic, inference techniques, knowledge engineering, propositional theorem proving, and the significance of logical agents in AI. I hope you found this video informative. If you enjoyed it, please give it a thumbs up, subscribe to the CSE Guy for more content, and leave your questions or comments below. Thank you for watching and see you next time.